Hello students. So today what we are going to see is the first lesson in class 8, that is rational numbers. Before getting into the lesson, I hope you all are safe and sound in your home. So let's get into the lesson now. So what a famous saying tells, mathematics is not about numbers, equations, computations or algorithms. It's about understanding. It's a saying by William Paul Thurston. What he means is whatever you see in max textbook or whatever you read or solve is not mathematics. What mathematics basically is what you understand from that. So try not to study simply, try to solve and understand as much as you can. That is how you get the complete mathematics. So what we are going to see in this chapter is rational numbers. What are rational numbers? Representing a rational number on a number line. Finding rational numbers between any two rational numbers. Understanding properties and perform four basic operations, which are addition, subtraction, multiplication and division on real numbers. So let's get into the first topic. What are rational numbers? Before getting into rational numbers, we need some basic concepts to understand so that the rational numbers gets much more easier. So we have learned something in our 7th class called as fractions. So we all know about fractions. We have already learned it. Let's recall what we learned. So fractions represent equal part of a whole or a collection. So what their meaning is, let's say I have an entire watermelon and I divided and I cut the watermelon in the middle. So now let's say we have two parts in the watermelon. So each part represents half of the watermelon. So this part we can represent it as 1 by 2, and the other part I can represent the same as 1 by 2. So each part is called as a fraction of a watermelon. The sum of each part gives us the whole part, which is 1. So that's what we call as fractions. This 1 by 2 and this 1 by 2 are what we call as fractions. Same way, if we cut the watermelon into 4 equal parts, each part will correspond to 1 by 4th of a watermelon. So the sum of 4 1 by 4s will give us 1. So let's have an additional information. The word fraction is derived from the Latin word fractus, which means broken. So what we are doing here, we are actually breaking the thing. So we are actually breaking the thing into equal parts. Hence, that's what fraction actually means in Latin. We have also seen various types of fractions such as unit fractions, proper fractions, improper fractions, mixed fractions and so on. Unit fraction is nothing but a single number which can be represented by a 1 on the denominator. Proper fractions. Let's get into proper fractions. Proper fractions are something wherein the numerator is smaller than the denominator. Here the 2 is the numerator and 3 is the denominator. We can see that the numerator is actually smaller than the denominator, wherein improper fraction is actually the opposite of it. Here the numerator is actually greater than the denominator. We can see that the numerator 2 is actually greater than the denominator 1. We all know what mixed fraction is. Mixed fraction can be represented as a proper or improper fraction by suitable operations, which we already know, wherein 1 by 2 can be written as 3 into 2 plus 1 by 2, which can further be written as 3 into 2 is 6 plus 1 is 7 by 2. Let's get into the topic rational numbers. Rational numbers are something which we are learning new. So what are rational numbers? Rational numbers are numbers which are in the form of a by b. A by b, where a and b are integers. We all know what are integers. Integers are numbers which contains both positive numbers, negative numbers with 0, and b is not equal to 0. Why b is not equal to 0? Because a denominator can never be 0 in mathematics. So real numbers are denoted by the letter q. Here so they are telling what numerator and denominator. We all know what numerator and denominator. The number on the top is called numerator and the number on the bottom is called denominator. Let's get to this chart. So natural numbers, we all know what natural numbers are. Numbers which are starting from 1 2 3 and so on are called natural numbers. Then the next is whole numbers. What are whole numbers? Whole numbers are numbers whole numbers are natural numbers with 0. So whole number starts with 0, 1, 2, 3, and so on. So next comes the integers. Integers are negative numbers plus the whole numbers. So integers goes like negative 4, 3, negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. So it contains a whole set of negative numbers, whole set of positive numbers plus 0. Then comes the rational numbers. Rational numbers, we already know what rational numbers are. Numbers which are in the form of a by b, and also decimals. Decimals are also rational numbers. We'll talk about how decimals are rational numbers in the further slides. So they have given some examples. For example, 1 by 3, 6 by 11, minus 3 by 5, minus 11 by minus 25 are some examples of rational numbers. Also integers like 7, 4, minus 4 and 0 are also rational numbers. Why? Because any number can be written as a denominator. Any number can be written with the denominator 1. It gives the same value. So any integer is a rational number. As I said in the earlier slide, the decimal numbers like 0.75, 1.3, 0.888, etc. are also rational numbers since they can be written in fractions. So how can we write decimals in the form of fractions? We have already learned this in our 7th standard. Okay, so let's see how to write 0.75 in terms of a rational number. Okay, so we have a number called 0.75. Let's count the numbers after the decimal point. We have two digits, we have 7 and we have 5. Hence we have to divide the number, hence we have to multiply and divide the number by 100. So what we get 75 by 100, which can further be simplified as 3 by 4. So that is how we can convert any number, any decimal into a rational number. So same way we can convert 1.3. We can write 1.3. So how many numbers we have after the decimal point? We have only 1. So we can multiply this number by 10 and divide by 10. So 1.3 into 10 will give us 13 and the denominator is 10. So 13 by 10 is in the form of p by q, hence it is a rational number. Same way we can convert any decimal number into a rational number. So all integers as well as fractions and decimals are rational numbers. So integers, as we have seen in the chart earlier, natural numbers, whole numbers, integers, fractions and decimals together forms the family called rational numbers, and rational numbers are represented by the letter Q. The word ratio in maths refers to comparison of sizes of two quantities of any kind. So we have learned about ratios already in our 7th classes. So we have seen certain numbers like 1:2 or 3:4. We represent ratios like this. We call this colon as is to. So what are ratios? Ratios are something which we can use to compare two numbers. Here we are comparing 1 and 2. And here we are comparing 3 and 4, where we use ratios in our real life. For example, if there is one teacher for every 20 students in class, let's say we have 20 students in a classroom and one teacher is appointed for that class. So the student teacher ratio, so the teacher student ratio will be 1:20. What it tells is for every teacher there are 20 students. So ratios can be written as fractions too. 1:20 can be written as 1 by 20. Hence ratios can be written as fractions. So that is where the name rational number comes from. So you can see ratios, rational numbers. So you can see how the word rational number comes from. The word rational numbers comes from the word ratios. So let's get into our next topic, which are equivalent fractions. So what are equivalent fractions? Equivalent fractions are nothing but fractions which are equal. Let's say we have a fraction. Let's say we have a fraction a by b. Okay, so we multiply this fraction's numerator a and b both by an integer c. Let's say we multiply a by c, a into c and b into c. So what we get is we get a new fraction. Let's say we can denote it as by d by e. So this fraction d by e will be equal to this fraction, sorry, will be equivalent to this fraction a by b. So let's take an example and we can explain this. So let's say we have a fraction minus 2 by 3. Okay, let's say we have a fraction minus 2 by 3. We are taking our integer as 5, so minus 2 by minus 2 into 5 by minus 3 into 5. So this will give you an answer of minus 10 by 15. So minus 2 into 5 is minus 10, 3 into 5 is 15. So this minus 10 by 15 is an equivalent fraction of minus 2 by 3. So whatever the value you get after solving this equation will be equal to minus 2 by 3. Hence minus 2 by 3 and minus 10 by 15 are called as equivalent fractions. Okay, now minus 10 by 15 can be said as an equivalent fraction of minus 2 by 3. Okay. Our next topic is rational numbers in standard form. So what do you mean by standard form? Standard form is nothing but the simplified form we can get after reducing a rational number. Okay, in other words, a rational number p by q, okay, a rational number p by q where p and q are integers is said to be in standard form when the common factor of the rational number is 1. What do you mean by common factor is 1? So let's understand this by taking an example. Let's take an example 4 by 5. 4 by 5 is a rational number. The common factor of 4 by 5 is 1, which means no other factor we can use to divide these two rational numbers. We cannot use 2 or 3 or anything. We can use only 1. Hence, this is the standard form of this rational number. And let's take a rational number as said here, 12 by 15. Okay, so what are the common factors for both the numerators and denominators? We obviously have 1 as a common factor and we also have 3 as a common factor. We can use 3 to divide both the rational numbers. Hence, since it has 2 common factors, it cannot be a standard form for this rational number, whereas it can be further simplified as divided into 4 and 5. It can be further simplified as 4 by 5, and since we already know that 4 by 5 is a standard form, any rational number which is not in standard form can be reduced to a standard form. So let's see how we can reduce any rational number to a standard form. Okay, so let's go by taking our previous example, which is minus 12 by 12 by 15. Okay, so what we have to do, we have to find the factors of both the numerators and denominators. That is the first step. So the factors of 12 are 1, 2, 3, 4, 6 and 12 itself. Same way factors of 15 are 1, 3, 5 and 15. So how do you find the HCF? HCF is the common factor. It's the highest common factor. So which is the highest common factor existing in these two? 3 is the highest common factor. Hence the HCF is 3. So the next step. What is the next step? We have to divide both the numerator and denominator by the HCF. The numerator is 12. Hence 12 by 3 will give you 4. The denominator is 15. 15 by 3 will give you 5. So what we are doing here, we are dividing the numerator and denominator by the HCF. So we are getting 4 and 5. Replace with obtained values. So replace the question 12 by 15 with the obtained values. We can replace 12 by 4 and we can replace 15 by 5. Hence 4 by 5 is the standard form of the given question 12 by 15. In the same way, we can reduce any rational number to its standard form. The first step is we have to find the factors of both the denominators and numerators and finding the HCF. Okay, the second step is we have to divide both the numerator and the denominator by the HCF. And the third step is we have to replace the given question with the obtained values. Hence we end up getting reduced form of a rational numbers. Okay, and let's see another example. Okay, here we have minus 18 by minus 42. Okay, so we have to reduce it to the standard form. The HCF of 18 and 42 is 6. You all know how to find the HCF, so there is no need of explaining how to find the HCF. We have to write the factors of 18, we have to find the factors of 42, in that which is the highest factor, that is 6. So 6 is the HCF. Okay, so what we can do, we have minus 18 by minus 42. First, whenever you have a fraction which has both numerator and denominator having a negative sign, you can convert it as positive 1 by 2 by multiplying the term with negative 1. Okay, so negative into negative, minus into minus gets plus, minus into minus gets plus. Hence we can convert this negative minus 18 by 42 into positive 18 by 42 by multiplying negative 1 on both the numerator and denominator. Okay, hence minus 18 by minus 42 becomes 18 by 42. We all know that the HCF is 6. So 18 by 6, sorry, 18 by 6 will give us 3, and 42 by 6 will give us 7. This is what the second step is telling. We have to divide the numerator and denominator by the HCF. The HCF is 6, the numerator is minus 18, the denominator is 42. We get 3 and 7. So what is this third step is telling? What the third step tells us, we have to replace the given question by the values which we found. Okay, so we have to replace minus 18 by 3 and we have to replace minus 42 by 7. Hence the given answer, hence the answer we got is 3 by 7. Okay, so that is how you find a reduced to standard form of any rational number. So what I said earlier, that is what they are telling again. A quotient of two numbers with different signs is a negative number. So understand carefully. A quotient of two signs with the two numbers with the different signs. Let's say we have minus 4 by 5. It stays as minus 4 by 5, or 4 by minus 5. It also stays as minus 4 by 5. Okay, so hence minus 4 by 5, 4 by minus 5 and minus 4 by 5, all three are same. In the same way, if both the numbers are of same sign, which means the numerator and denominator are of same sign, we can write it as a positive term. For example, let's say we have minus 3 by minus 4. We can write it as positive 3 by 4. Okay, so how we can write it as, we can multiply minus 1 and divide by minus 1. Okay, in this term, in this way, this negative and negative gets positive, this negative and this negative gets positive. So any number, any rational number with both denominator and numerator having negative sign gets converted into a positive rational number. Same way, if it has only one, either denominator or numerator has a negative sign, only one has a negative sign, it stays as a negative number. Okay, that is what you have to keep a note of this. Okay, so let's get into the next topic, which is comparing rational numbers. Okay, what do you mean by comparing? Let's say I give you two different boxes and I'm asking you to find which different box is having more food. Without opening, you have to tell. What do? You take both the different boxes in both the hands and you measure the weights of both the different boxes, and you can tell which different box is having more food. Same way, let's say I give you two numbers, let's say 100 and 90. I'm asking you which is bigger. You obviously know which is bigger. 100 is bigger than 90. Same way, if I give you negative numbers, let's say I give you minus 3 and minus 5, which is bigger? You can all tell minus 3 is bigger than minus 5. Why? Because in negative numbers you have to apply the opposite of positive numbers. Okay, whereas in positive numbers 5 is greater than 3. Okay, so we are completely done in we are completely good with comparing integers. So what we are going to do here, we have to compare rational numbers. We have to compare two rational numbers, which is bigger or which is smaller. Okay, let's go by an example. We have to find which is greater, minus 10 by 3 or 14 by minus 5. Okay, so first let's make the denominators positive by writing 14 by minus 5 as minus 14 by 5. We have already learned that minus 1 by 2 is nothing but 1 by minus 2 or minus 1 by 2. All 3 are same. Okay, so there is nothing wrong in writing minus 14 by minus 5 as minus 14 by 5. In this way the denominator becomes positive. Okay, so now we have two positive denominators, 3 and 5. So that is your first step. You have to make the denominators positive. So what is the second step? In the second step you have to find the LCM of denominators. Okay, so how do you find the LCM? You all know how to find the LCM. So you do something like this: 3 and 5, you multiply the first thing by 3, so 1 3s are 3 and 5 stays the same. Then you multiply by 5, 1 stays the same, 1 5s are 5, so 3 into 5 is 15. So the LCM is 15. Okay, so the LCM of 3 and 5 is 15. Okay, so the next step is we have to make the denominators same by taking the LCM. How do you make the denominator same? We have to multiply and divide by certain number such that we get denominators as the LCM. Okay, so here what we are doing, we are multiplying by 5 and dividing by 5 such that 3 into 5 gives us 15. So here what we are doing, we are multiplying by 3 and dividing by 3 such that 5 into 3 gives us 15. Okay, you have already learned this method in your 7th class, so there is nothing difficult in doing this. What you have to do, you have to multiply and divide by certain number such that the denominator becomes the LCM. Okay, so now we have two numbers, which is minus 50 by 15 and 40 minus 42 by 15. So let's compare the numerators, minus 50 and minus 42. Which is greater, minus 50 or minus 42? Since these are negative numbers, minus 42 is greater than minus 50. Hence minus 42 by 15 is greater than minus 50 by 15. Therefore what is minus 42 by 15 corresponds to? Minus 42 by 15 corresponds to minus 14 by 5. And what is minus 50 by 15 corresponds to? Minus 10 by 3. So that is how you compare any two rational numbers. Okay, let us see how to write the given rational numbers in descending order or ascending order or anything. Okay, descending or ascending order. So we have been given some set of numbers such as minus 3 by 5, 7 by minus 10, minus 15 by 20, 14 by minus 30 and minus 8 by 15. So we have to write these numbers in descending order. That is what the given question is. Okay, so the first step is to make the denominators positive. How to make the denominators positive? So we have already seen that we have to just shift the negative sign on the denominator to the numerator. Okay, so what we are doing here, we are making 7 by minus 10 as minus 7 by 10. In the same way we are doing 14 by minus 30, 14 by minus 30 as minus 14 by 30 and so on. Okay, such that all the denominators becomes positive. So what is the next step in comparing rational numbers? The next step is finding LCM. So we have to find the LCM of 5, 10, 20, 30 and 15. So we all know how to find the LCM. I have told a little bit earlier. So the LCM is 60. Okay, if you find the LCM, you have to find the LCM by yourself. The LCM is 60. So what is the next step? We have to multiply and divide by certain number such that the denominators become 60. Okay, so let's take the first number, minus 3 by 5. What number we should multiply to 5 such that we get the denominator 60 here? So it's obviously 12. So we should multiply 5 by 12 to get the 60. Hence we have to multiply the same number on the numerator also. So minus 3 into 12 becomes minus 36. In the same way, what number we should multiply to minus 10 such that we get 10 such that we get 60. So we should multiply the number 10 by 6 such that we get 60. Hence we have to multiply the numerator also by 6. Okay, 7 into 6 will give you 42. Hence in the same way we have to do for all the numbers. We have to multiply 2 into 30 so that we get 60. Hence we have to multiply 2 on the numerator also, we get 28. Okay, after After writing all the equivalent forms of the given question, the equivalent form of minus 3 by 5 is minus 36 by 60. Same way, minus 7 by 10 is minus 42 by 60. After writing equivalent forms of all the rational numbers given in the question, after writing equivalent forms of all the rational numbers given in the question, let's move on to the next slide. Okay, we have to compare only the numerators on the given question, that is minus 36. Let's go back and check. Minus 36, minus 42, minus 45, minus 28 and minus 32. Okay, so see, so here we are comparing only the numerators. Okay, so we have to write these numerators in descending order, starting from the biggest number. Here minus 28 is the biggest number in the series since it is a negative number. If it is a positive number, minus 20, if it is a positive number, 28 will be the smallest number in the series. Since it is a negative number, minus 28 is the biggest number next to minus 32, and next comes the minus 36, next minus 42, and then minus 45 is the smallest number in the series. Okay, hence corresponding to that we have to write the actual forms of this number, which is minus 28 by 60, minus 32 by 60, minus 36. We have to write these numerators with its denominator. With its denominator is what is the LCM. Okay, hence this is the descending order of the equivalent fractions. Okay, so what are these equivalent fractions? These equivalent fractions corresponding to certain rational numbers given in the question. The equivalent fraction of minus 28 by 60 is 14 by minus 30. How do we know that? We have already seen that, we have already calculated that the equivalent fraction of minus 28 by 60 is 14 minus 14 by 30. Same way, the equivalent fraction of minus 32 by 60 is minus 8 by 15. So we have to write the corresponding equivalent fractions of the given question. For minus 28 by 60 it is minus 14 by 30, and minus 32 by 60 it is minus 8 by 15, and minus 36 by 60 it is minus 3 by 5. Hence this is how we are writing any given set of rational numbers in ascending or descending order. Okay, so what is the first step? The first step is to make the denominators positive. The first step is to make the denominators positive, and the second step is to find the LCM of all the denominators. The third step is to convert the given rational numbers into equivalent fractions having same denominators. Okay, and the next step is to arrange the numerators in ascending or descending order, whatever is asked. Okay, here we have arranged in descending order, and the next step is to write the given numerators, write the arranged numerators with its denominator. Okay, so and the next step and the final step is write the corresponding equivalent fraction of the arranged fractions. Okay, so that is how we write our ascending or descending order of any given set of rational numbers. The upcoming slide will have your assignment questions. I'll just keep the assignment slide for a while. You can just pause and write the assignment questions, and you can submit and send it to your class maths teacher, or you can put it in the class group. Okay.